Let us start partial derivatives. Before starting partial derivatives, let us discuss what we have learned about the function y is equal to f of x. During our school education, we learned all kind of properties of the functions y equal to f of x. For example, evenness, oddness, the function is 1 or not, the function is onto or not, right? And in the analytic property, we have seen whether the function has limit at particular point or limit does not exist. If limit exists, then whether the function is continuous at a particular point or not. Now suppose the function is continuous at particular point, whether the function is differentiable or not, that is f dash x exists at x0 equal to a. And in the other part, we have seen if function is continuous, then what is the integration of f of x dx? Integration, we have seen two different things, the integration and integration over the closed interval f of x dx. Okay, now let us expand the function y equal to f of x to the multivariable. So for y is equal to f of x, what we are doing? We are choosing our x from the domain, and this is the codomain axis where we have value y. So suppose this is a function y is equal to f of x. So we pick x here from x axis, and then we have corresponding the value y. And so this point is xy. Right. So now x is the real line, y is also the real line, and the dimension of this is 1. The dimension of this is also 1. Right. So this structure y is equal to f of x is in plane, which is 2 dimension. Now suppose you learnt surfaces also during the school level. For example, x square plus y square plus z square equal to 1. So what is z here? Z square is 1 minus x square minus y square, and therefore z is equal to either under root 1 minus x square minus y square, or z is equal to minus under root 1 minus x square minus y square. Okay, so what is happening here? That we are choosing the values of x and y, right? So for the particular point of x and y, we have the value z, and this is z axis, right? This is z axis, and x square plus y square plus z square, you know that that is sphere, right? So sphere of this kind. So this is the sphere with center 0 0 and radius 1. Okay, so x square plus y square plus z square equal to 1, the sphere is 3-dimensional structure. So how it is 3 dimension? We are choosing 2 tuple x and y, which is 2-dimensional, and the answer, which is z, is one more dimension, right? So here the function f is this. We are choosing xy from the plane, and this is our codomain R. So the 2 dimension from here, 1 dimension from here, right? So the function z is equal to under root of 1 minus x square minus y square, or this one minus under root 1 minus x square minus y square is 3-dimensional structure. We can extend this concept up to n dimensional. So suppose I have given the point x1, x2 to xn. So this is the point from n dimension, right? I have given some function f, suppose w, then its drawing is total n plus 1 dimensional structure. N plus 1 dimensional structure. But as you know, we are living in 3 dimensions. So in 3 dimensions, we cannot draw any structure which is 4 dimensional, 5 dimensional, or more than that. Clear? So now let us define level surface. What is level surface? We shall discuss this with particular example also. So what is the level surface? The set of points, x1, x2 to xn. Keep in mind this is n dimensional point, is called a level surface, for our function w is equal to f of x1, x2 to xn if for a real number c f of x1, x2 to xn is equal to c. So this is called the level surface for the value of c. When c is changed, the corresponding level surface is changed. Right. Now let us try to understand this with some visualization. For example, I have given this function that is equal to f of xy. Right. For example, my function is say z is equal to x square plus y square. Then how z is equal to x square plus y square looks like, and which are its level surfaces. So for level surfaces, what we do for a real number c. So suppose c is equal to 1, then the corresponding level surface is x square plus y square equal to 1. When c is equal to say 4, then x square plus y square equal to 4. Right. Because for c is equal to 1, I have z is equal to c, which is equal to 1. So x square plus y square equal to 1. Right. We are substituting the values of c here. Clear? What is this x square plus y square equal to 1? You know that this is nothing but the circle with center 0, 0 and radius 1. This is also circle with center 0, 0 and radius 2. You know all such things, right? But how they look like, that we are just let us observe this structure. Okay, so this is the curve that is equal to x square plus y square. So as you observe that blue axis is z axis, right? And x and y are represented by red color and green color and red color respectively, right? And this is the graph z is equal to x square plus y square. Now when we choose z is equal to 1, z is equal to 2, 3, 4, they are known as level surfaces. So how the level surface looks like here? So say okay, so okay, so say this one, when the value of c is equal to 1.5, when the value is 2, right? So actually the level surface is this. When z equal to 2 is the plane, right? So when x square plus y square is equal to 2, so this is the circle, this interior circle, you are observing this interior circle, right, is called the level surface, and the level surface is actually up to this level, the level z is equal to 2. So the circle lies 2 units above to the xy plane. Now, if we increase the value of c, then see this. When the value of c is equal to 3, we have this circle, right? So, whenever we are changing the values of c, the level surfaces are going up. This is when c is equal to 5. So this is the circle with center 0, 0 and radius square root 5. So this is the level surface, right? Now, after level surface, we have another word which is called contour. I am not giving the definition of the contour, but let me explain what is the contour, right? So see, whenever we have drawn all these level surfaces, then the projection of the level surfaces on xy plane represents the different circles. Those different circles are mentioned here with dotted circles. So each circle on the xy plane, which is the projection of the particular level surface, right, is called the contour. If the curve is closed, then it is called closed contour. Here circle, obviously it is closed curve, right? So it is called closed contour. If it is open, then it is called open contour. Now let us see this, how we are using the level surfaces and contours to our practical life. Okay, so say this is, here I have mentioned the level surfaces of Janskar region, right? The Janskar region situated in the Himalayan series of India, right? So if you just you can observe that, right? So these are the level surfaces which represents the particular level, right? And this one is also, right? Now if we take the projection of this particular kind of level surfaces on a plane, then those represent contours. Now I have mentioned here the contours of the Mount Everest. This figure represents the contours on Mount Everest. Which are the contours here? So this is one contour, this is another contour, this is one more contour, right? Now, so when we are going with the bigger contour, right, actually we are going to the base, and the innermost represents the peak of the Everest. So this contour is the peak of the Everest, and this may be near to the base, right? So this is how we can plot the three-dimensional structure with the representation of level surface and contour.